Okay, we are going to look at section 9.4 homework. Um, Here we're looking at several things similar to what we did earlier, but we're looking at the Z, the one tail lower test, and it's asking us to find the p-value. And what you can do is find the p-value by using the table, and then later we're going to use StatCrunch to find the p-value. But we see that alpha is 0.05, and we're using the z-table, the normal distribution table. And we're looking up z at negative 1.19, which would be right here, and here's our p-value. So that is how you find the p-value using the table. And if your p-value is less than alpha, you would reject. So we see our p-value is 0.1170, so that's greater than alpha, so we would not reject. And then you do the same thing for the next problems, one tail. And then let's look at C. Find the z value of 1.94, and this is a two-tail test. So what you will do is you would find 1.94, 0, 1, 2, 3, 4, and that would be up to positive 1.94. So you would do 1 minus this, and then you would double it. Another way to do it is just to look up, since it's a two-tail, is look up negative 1.94, 0, 1, 2, 3, 4, and take that value, 0.0262, and double that, and you can get 0.0524. You don't have to subtract because that's the left tail. That is actually the area of the left tail. So to get the area of the right tail, it would be the same thing on the right side. The tails are the same, so you could just double that. That's a quick way to work that. So for the last one, a two-tail test, we could go to the negative value and get that, negative 0.84, and we 0, 1, 2, 3, 4. So the area of the left tail is 0.2005, so we would double that, and we would get 0.401. And 0.401 is greater than alpha, so we would not reject it. So moving on to question 2. Here you're doing the same things. You're looking it up using the table. And then question 3 is a hypothesis test. Given that P is 0.175, N is 160, and alpha is 0.10, answer the following questions. And so, first of all, the critical value, let me show you how to do that, because you've got to make sure, and you can write these down, these critical values here, to remember them. But if you just want to look these up, go to StatCrunch and go to calculators. Stat calculators, and do the normal. And what you can do here is, let me minimize it. You don't have to fill out the mean and the standard deviation, but we do need to find out alpha. And this is a one-tailed test because it's got the greater, it doesn't have the equal to. It's greater than or equal to, and less than or equal to and greater than. It's not equal and not equal to. So this is greater than, so this is a right-tailed test. So if the alternate is greater than, that means it's a right-tailed test. And we know that alpha was 0.10, so you would put 0.10 here, and you see that your z value is 1.28. Now, to get the actual test statistic, what you need to do is go to proportion stats, because this is a proportion, and go to one sample with summary. And the number of successes, to get that number, you have to say, and I haven't done this, so I will have to calculate this. The successes is 0.175 of 160. So 160 times 0.175, and the successes are 28, and the observations are 160. The hypothesis is 0.16, and alpha is 0.90, and then you hit compute. Hold on, I accidentally put too many decimals. Compute. And you'll see that your z-stat is 0.52. Okay, so we'll go back to that in a minute. Alright, so if we were to draw this out, and I'm going to continue to draw these because I want you to understand, if you haven't watched a previous video, how to decide if you need to reject or accept. So if you draw a normal distribution, here is the mean. Here your critical value is positive 1.28. So that critical value tells you in a right tail test, this area I've filled in is the rejection area. So I will reject the null if my test statistic is in that area. As you can see, 0.52 would be on the other side of 1.28. So since it's not in the rejection area, we cannot reject it. There is insufficient evidence to show that the alternate is true. There's nothing that shows that, so we can't reject the null. Now, as far as to calculate the p-value, what you need to do is you need to actually, the p-value is the value you put in your test statistic and the probability of finding something greater than that. So 0.302. And you can read more about the p-value in your PowerPoint slides, or you can view an example. I'm just showing you how to calculate in this video. So moving on to question number 4. So this is a two-tail test. So you determine your critical values. I will go through this one just to show you a two-tail test. So here we know that alpha is 0.10, but since it's a two-tail, we would put 0.05. So our critical value is positive 1.645 and negative because it's a two-tailed. Now to calculate your test statistic, remember you go in back into where, well, I'll just show you so we can review it. Proportion, one sample with summary, and then your number of observations is 250. Your number of successes would be 0.46 times 250, which would be 115. And your hypothesis is 50-50, and your confidence level is 0.90. And hit compute, and you can see that your z-test statistic is negative 1.26. Now, when we look at a two-tail test, here is our normal distribution. Here is negative 1.645 and a rejection area in the left tail, 645. Let me fix that. And here is positive 1.645, and here's the area of rejection in the right tail. So if our test statistic is right here, that means we can't reject the null because there's not enough evidence to support the alternate, which we were trying to see. if it would. And then the p-value, go back to where we were. Stat, calculator, normal. And the p-value is, you put in the test statistic. And this is a, hold on just a second. So we take, I had it right, less than or equal to, we take this number, negative 1.38, I believe, and we double it 0.206. And we should get 0.209. This one's a little bit off here, and I'll have to go back and see why that this number is off a little bit. We could go into proportion stats. Let's go back and look real quick. .06. I'm not sure why that is not calculating right, so I'll have to go back and check on that one. I want to finish this video before we run out of time. This is the same thing here. You work it the same way, but you don't have to figure out your number of successes. They actually tell you 80, and then 200 is your number of observations, and you work it the same way. And then you determine your p-value for this test. And I believe that, let's just do this one and see if it will work. If we go to stat calculators and do a normal, and we do 0.58, and this is for a right tail. So greater than or equal to, and then we do 0.58, and we get 0.281. Let's see if that's right for a p-value. Yes, 0.281. So I'm not sure. I may have miscalculated, or I didn't explain it very good. Question 6, same type of situation. You just have to set up your hypothesis right, and the way you do that is you read the wording concerned that the proportion is increased. So the alternate would be increase would be greater than the 20%. And question 7 is still the same types of calculations, and StatCrunch can do all these calculations for you. You can look the z-score, the critical values up by hand, and the test statistic, you can work it by hand. But for time purposes, just use StatCrunch and mainly practice on the null and know when to reject the null and when not to reject the null. Understand that, and then you will have understood the basic concepts to hypothesis testing. And then, of course, alpha, read about it in this example. You can read about alpha and the type 1 error. And that is pretty much all of section 9.4 homework.